There is never a good time to have an engine failure, but there are worse times to have an engine failure, which is why we have a whole brief just about engine failures after takeoff. So we've already brushed on engine failures in the circuit, but that was at 1,000 feet. This is going to be a very different situation. So there's a different procedure, which is why we have a whole brief on it. And this one will take about 30 minutes, approximately. Our objective was that instead. That's a good start. We should go halfway through yours. Sorry, dude. Suffocate it with a pillow.
9G deceleration.
Right, there we go. We're back. Okay, so objectives. To adopt the recommended procedure in the event of an Efato engine failure after takeoff, or an aborted takeoff. So you might have heard of Efato before, that's what that actually means. This is what we've deemed as the most correct way. There are going to be times where you might have to be flexible, but we will go through the exact way we expect you guys to do it. Okay? So why? To know how to react in the event the aircraft suffers a power reduction or total loss at low level below 1,000 feet. We're really going to focus on the total loss, so a complete engine failure. We'll brush a little bit on power reduction. We will talk more about power reductions later. Practice to develop an automatic response to a critical situation in flight. That's a big part of our flight training, right? Is we want to really know exactly what to do if the worst were to happen. So that automatic response is really important because stress and adrenaline can really kick in. Note it's that below 1,000 feet. So we already kind of brushed on what happens at 1,000 feet in the circuit, which was the glide approach. And later on, we'll look at engine failures above 1,000 feet, and what we call practice forced landings without power. So here we are focusing on engine failure after takeoff, and that might not necessarily actually mean we have just taken off. It could be going around somewhere. It could be just we've had an engine failure below 1,000 feet anywhere else. It could be we are low flying, so we have an engine failure. So for simplification, it's just an engine failure below 1,000 feet. The big consideration here on why we're doing this is to survive, right? This is a really bad situation. The aircraft has had an engine failure very low. If we don't do this procedure properly, it can kill us. So it's very important. Are you wearing a different hat on?
Yes.
Anyway, it's kind of crashy. No, we're good. This is really where that old adage of any landing you walk away from is a good one, right? This is really what we're talking about, is an engine failure to take off. If you walk away from it, that aircraft is going to be a little bit beat up where it's landed, but definitely looks intact, looks like the people walked away. That's a fantastic outcome. I believe that's a Massey aircraft in the Southern Training Area. Yeah, it's got questions here saying, do you think this was a successful outcome? So you can ask the students that. Hopefully they say yes. It's all in one piece, that's a good sign, right? could have caused that engine failure? So, this is going to be a bunch of questions being asked. So, what are the four main things we're talking about here? I don't think you've got the notes in front of you. Someone can tell me.
Fuel, air, spark, mechanical.
Cool, okay, I need an example of every one. Fuel, what's an example?
Contaminated fuel.
Cool. What else? This is really not a big spark. What could happen there? Plug failure? Yeah. Mag failure? Yeah. Anything like that? The spark is not igniting, or there's no spark? Yeah, what could happen?
Block, air.
Engine air intake becomes blocked by examples?
Feathers. Bird.
Bird and what, sorry?
I said feathers, but like.
Anything bird related? Like a nest?
Yeah.
Ice, fod, anything, right?
Plastic bag.
A plastic bag, definitely. And mechanical, what are we talking about there?
Mechanical fuel pump.
Mechanical fuel pump. Yeah. Will that be mechanical or fuel? Yeah. Because that would be an example of fuel exhaustion or fuel starvation.
Starvation.
What's the difference?
There's still fuel in the aircraft. Just
Yep.
can't.
Exhaustion is we've used every little drop. Starvation is we can't get it to the engine. Cool. So you can really have a big discussion here and talk about a lot of different examples here with the students, because this is their first time seeing this, and then you kind of recap it in the forced landing mass brief, which you can once again ask a few questions, but take your time on this one in particular because it's their first time. So go through a heap of examples. The big thing to point out is, what do we as the pilots control in regards to those four? It's a bit of a trick question. We have some control over everything, right? Probably the most control we have is over the fuel, which is why there's quite a few steps on getting fuel. And we check it, and we take a fuel log, and we keep an eye on that fuel log, and we set a fuel scheduler, and we have our fuel endurance noted at the start. You know, that's why we do all those things with fuel. That's why we do the fuel drain before every flight, even if you were in the pilot monitoring beforehand, you should still be doing the fuel drain. That's why whenever you get the plane, typically you should be draining the fuel once you get it, and then you should put fuel in it and then drain that again, right? No, not everyone does that, but the idea is you check it for contaminants before you put more fuel in and use that fuel if it has contaminants in it. Air, that's all in pre-flight, right? Is everything clear? Pre-flight and then run-ups, and that goes the same for spark as well. Mechanical, I mean, that's going to be your pre-flight, checking your documents, checking that everybody else has done their job in regards to the aircraft. Because your job as the PIC is to make sure that the aircraft is good to go, therefore has everybody else done their part. And then of course just your general, like I said, pre-flight and run-ups in. So we don't have full control over everything, but we do have quite a lot of control when we think about all the things we do to get the aircraft good to go. And the main cause for engine failures is usually the pilot's missed something. Every now and then some mechanical failure happens and there's nothing we could do, but most of the time we can catch that stuff in at least the run-ups. You could also, in regards to teaching this in a class, you could break everybody up into 4 groups and get them to list specific examples for their group, as in put them in a fuel, air, spark or mechanical group. Just to get a bit more involvement from the class. And then you can bring up that after they've been in their groups. It says others in 5. I mean, you could chuck that under mechanical, right, or spark or whatever, but we can kind of, wouldn't be surprised if a couple groups put that in. And you can go through this group by group and go, alright, fuel, what have you got? Alright, spark, what have you got? Which they probably haven't got much. Compared to fuel. And we talked about all those fuel things. Yeah, we've talked about mechanical, yeah. Yep. Right, what were our best glide speeds again? 1,200,
76.
1,150,
73.
and 1,000. Yeah, I mean, this is mass brief what? Where is this? 60 or something? Yeah, 16. So they should know, you know, you should be able to ask a few more questions and expect a few more correct answers at this point. Right, really important point to make here because the students always want to do this. So bring it up in steps. Our best glide speed, depending on our weight, let's say we're 1150, so our best glide speed was 73. So that is what we're trying to achieve with our best glide speed, right? We're going to get the most distance travelled in a given time. If we are to fly at a faster or slower speed, what's going to happen to our distance travelled in that given time?
Reduce.
Reduce. Cool. At a higher or lower airspeed. Really important to point that out. If you are getting low from the field that you've selected, lifting the nose up and flying slower will not get you to that field. Make sure you emphasize that to the students. So that best glide speed gives us the best range. Takeoff brief. This is something you would have heard your instructor blab on about, and you've probably been sitting there going, what are they saying? So you're just describing this to them. It's a standard brief for both normal and abnormal procedures that you conduct for each event. So this is hopefully going to take a little bit of the surprise factor out of an actual engine failure after takeoff. And it also helps make sure that the entire crew is on the same page in regards to an emergency like this. So we do it on the ground before we line up. So can anyone tell me at what point in their checklist they usually do this? Anyone know? What's checklist?
End of pre-takeoff.
End of pre-takeoff's cool. So right before you're doing your lineups, right? And this can be a bunch of questions, you know. Why would we do this? So give intentions a PIC is for the crew, right? So the crew knows. And you can give other examples that don't have to be a takeoff brief. For example, when I was doing a flight with Pika and the twin, and we had our problem with the hydraulic system. And as we were coming into land here, he briefed the crew on exactly what we were going to do. So we were going to land, and he said if anything happened with the gear and it collapsed or anything like that, he wanted me and the pilot monitoring to exit while he remained in to turn everything off. So this is him briefing us as we're coming into land here. And he was just, you know, describing the problems that could happen, and this is what we're going to do if this happens. So that's so important in regards to give intentions of the PIC. Of, you know, make sure everyone's on the same page. Make sure everyone knows what their role is or what's expected of them. Just like, you know, when we do forced landings and we give our passengers a brief, you give them something to do, give them something so they know what the expectations are. So improve situation awareness, because in our takeoff brief we're going to point out the wind direction, talk about any terrain, talk about any hazards. So it just really helps us kind of set up what we would do. Like I said, take the surprise factor out of it. So then we go through our example, which I believe this is straight out of the SOPs. So this will be a normal or a short field or a crosswind takeoff on runway whatever with a left or right turn to track north or south, climbing to 1,100 feet or 1,500 feet. So you're kind of just filling in the blanks there. In the event of abnormality, so let's just break that up actually. So we've talked about what we're going to do normally, right? This is exactly what we're expecting to actually happen. and then let's brief just in case we have an emergency. So in the event of any abnormality on the ground, I will abort. Engine failure airborne. I will carry out standard emergency procedures. Landing in a field to the right, away from, let's say it's Saracen, to the left away from Calvin Grove. You know, make something a bit specific. We should go through some examples soon so we can kind of talk about how specific we can get anyway. So I go through that, and then I might just get the students to come up with an example, give them a scenario, and get them to give a brief in regards to that scenario. Or you can start by making it very specific anyway. Either way, you're about to go through kind of how you're feeling. So taking off from runway 25, hopefully this is a familiar picture to you all. Looking at the fields, what things do we have to look out for here? This might be a bit tricky with the... Is it done eventually? There we go. Right, is that better?
Yeah.
It's more dark and sad in here.
More dungeon-like.
Yeah. So think about, like, we are straight after takeoff, right? So we are facing directly that way. Think about the way that the fields are running, where the fences are. What other things do we have to look out for? Trees, yep. Buildings, power lines. That's the big one you can't really see easily, eh? At least we can see the trees. Power lines are somewhere on there. You guys can see them making. Like here?
Somewhere leading power lines around there.
I feel like it's just there. Oh wait, is it? That's it there, I think. There's one there.
There's one
We don't like it here. So yeah, 2.5 doesn't sound too bad, but when you really look at the details, it's actually not great, as we probably will notice doing photos out there. There are a couple good options, but you might find that you will have to, let's say we wanted to get into this field here, we might have to turn to the right and then left to get them. We might have to maneuver ourselves appropriately. Don't feel like you have to land directly, let's say we try and land directly this way. You can land diagonally through a field, eh? You actually find there's more length if you land diagonally. We're not looking for the perfect field, and we will talk about this in more detail. We're just looking for a safe place to land. Think back to that picture at the start, that successful outcome landing, you know? If we can walk away, then fantastic. So 07, a little bit less desirable. We've got the suburb here, Calvin Grove. There are some great fields here. It's just, do you think you can make it into that field at this current height? Probably
Flat.
not. A little flat, maybe with a bit of turning going on.
Yeah, then it's
Yeah. You might be better off going for something out here, or maybe even this one over here, depending on wind and all sorts. But yeah, I guess it's just to note that there aren't always fantastic options, and you are going to have to make do with what you have. Right. I don't need to teach this to you guys because it's pretty straightforward, but what I would do is start writing the things on the board on how to actually do the Efato. So I would start with, aviate. Make sure that aviate, navigate, and communicate are all in a different colour and capitals or whatever. So first thing we're going to do is lower the nose, set our best glide speed, whatever that may be. Make sure we trim. So aviate isn't just set an attitude and then start going through other stuff. Make sure you take the time to trim it. Make sure you've got that best glide speed, because that's what's going to give you time, and it's so important that we have the aircraft under control. If you just do lower the nose and get your best glide speed, you're going to have a much better chance of surviving than if you did everything else but that. So that is the vital, most important thing to do. Once you've got it set and you've got it trimmed and you're happy, then you're going to follow what you briefed. So you're going to look for an appropriate landing site or the best option. That might not mean a good option, that might just mean the best option. Use flap as required, avoid major obstacles, and keep the cabin intact. What do I mean by keep the cabin intact?
Trees go.
Yeah, cool. That's very specific, but yes, that's exactly what we'll get to as a good example. So make sure that your cabin is not the thing that's aiming at the brick wall, right? The wings can fall off and we'll be fine if we're on the ground. The cabin is what is got us in it, so we need to make sure that we're kind of aiming that at the safest spot. So yeah, definitely, easiest way to sum that up is you've got a line of trees, you're going to aim the cabin in between the trees. We brushed on this a little bit with our circuit consideration mass brief, but flat is used only when you're really sure that you're going to make your selected field or clear area. Alright, here's another example of a bunch of fields. So where would you go? And you can get students to come up and blank and get them to describe. You can even pass the pointer around and get them to just point out whatever field they'd go for. Up to you how you want to do it. Are there any obstacles here that we need to look out for? See, they're not quite hard for you guys to see. I don't think there's power lines on this one, is there? There might be a power line over here. So, really hard to see. Can't see it on here, but I can see it on there. Either way, you've got some good options. A fence is a big problem. Not ideal, if we can get away with not hitting one, but if that's our only option, then go for the fence, sure. But yeah, plenty of options. The only things we need to avoid here are the trees, maybe the ditches. Some ditches look pretty decent, and of course the water. What about here? Does anyone know where that is?
Training area.
Out,
The southern training area.
it's out by the coast next to Foxton, there, isn't it?
You're on to Wanganui.
It looks more like it's out towards like Wanganui.
Yeah. So has anyone been to Wanganui before?
Oh, yeah.
Yeah, I've been there at least once, maybe on your PPS, because we used to do PPS there all the time. Richie. So this is runway 11, and you can get the students to bring up the plate and actually have a look at it, because actually, do we bring up the plate? No, we don't. Because you can see that it's right by the coast, and trying to think. Yeah, so this is facing south along the coast. So when you're going north, and you'll see it soon, hopefully, you got the river mouth. So you don't have the river mouth here. So you've got a lot of scrub. Would you go for the beach?
Is there a beach?
It's high tide at the moment, right? Looking at that picture, so it's not a good option. And yeah, definitely, is there a beach? Is it just a cliff? Because that's a big question, isn't it? So being familiar with the area is going to help you a lot, which we're not very familiar with, really. But if you were to go there, hopefully you have a good look at your plates, and if you're doing a standard overhead join, that's a great place to actually look at both ends and look at your Efato options. So that clear area ahead, if we zoom in a bit more, so we've moved on a little bit more, it's not great. We've got a lot of gorse around here, but we do have this kind of little strip going into sand, so that might be your best option. Of course, we should be well clear of those trees, so it's just going to be a bit of scrub. It's really hard to tell the slope, but it is quite hilly around here as well. So it's not great, but that's a good example of there's not always going to be a field as such. It might just be a clear area. Here we go. There's runway 29 at Wanganui. These are mirrored pictures, which makes it slightly confusing. But this is going north. Like I said, it's mirrored. Where would you go?
Probably the beach.
Yeah, probably the beach, yeah. And you're judging where to land based on where that water is. You can see it's kind of smoother here in that lighter bit, but it could be quite soft as well. So there's a few things to consider. You might be best just to go on this spot here and try to land as nice and controlled as you can. Where is this? Where would you go here?
The runway.
Everest one.
Water.
take off.
But,
Always go
Get in the drink.
And then we watch a 30-minute video on ditching.
Yeah.
Yeah, so lots of different kinds of aerodromes. You're going to have different problems and different things to brief in regards to Efatos. The Efato brief here might be we're going to make a left turn and land in the water next, as close to the land as we can. So we can hopefully swim to shore. Yeah, so you're just going to make the brief suit the situation. One thing we want to make sure we never do if we have an engine failure have to take off is turn back. Why do you think that is?
we have so much more, we lose so much more altitude in turn while we're turning, so we're never really going to be able to make it back off a regular climb.
Yeah, that's the big thing, right? Is you're going to try to do a steep gliding turn. Not even a steep gliding turn, but it will probably be pretty steep. But you're trying to do a gliding turn, and in a gliding turn, you're going to lose a lot of altitude. So just to put that into perspective for you, I'm play a little animation. So we're taking off on runway 07. We have an engine failure at 600 feet, which is pretty generous. It could happen lower. We started turn, and at this point we've turned 180 degrees. And in approximately 180 degrees, we've lost 300 feet. Now, it's not just a 180-degree turn to get back to the field, is the thing to note, because now you have to turn back towards the actual field itself, which is another 90 there, and now you're turning back onto final, which is going to be another 90. So, as we saw, 180 degrees is 300 feet, so if we're doing a 90 and then a 90, we're losing another 300 feet. And there we are at 0. So yes, as Callum said, we do not have enough height in order to turn back. Now, this is the disclaimer part that I would not tell a student, but of course there might be situations where turning back is an option. Everyone's happy with that, but you would not talk about that in this case brief. Cool? I believe, who's had an Efato? No, PK has had one, and he said they turned it back. It's going to depend on so many conditions, right? But your point you were saying to the student is never turn back. This is why we are trying to get them to survive, and the easiest way for them to survive is to keep that 75 or 73 knots, whatever it may be, and keep the aircraft under control. If they start doing a turn and they start panicking because they see they're losing height, it's not going to end well. So really important. Now there is did you guys get play the video when you saw this mass brief?
Don't remember.
You got the person turning back?
Yeah. You did?
Probably at some point. I don't know.
I'm gonna try to find
Wait, yeah, I used to. I was upset with turning back. Just like the physics of someone pulling in. Makes me always remember. Not to that we are in. Then I watch it like 5 minutes before I brief DI and then 5 minutes before I went there. And then I still forget.
on a 1 hour video. I don't think it's full. This one might be so give me a couple minutes. hold on, I think I found it. Unfortunately. Disregard, I have to sign in. I'm not gonna do that. There is a, just see if I can find it on my phone actually, because it'd be nice if I can find the right link, just to give you guys a source. So when I was a student and instructor delivered this mess brief to us, she played, I don't know if it's this video, but she played a video of a aircraft crashing after they tried to turn back on Efato. And she replayed the video like 3 or 4 times just to like make it sink in. And it was pretty like brutal. But you know what? I never forgot it. So it worked quite well on her part, you know?
Little emotional damage. And there are the layers.
Yeah, that's weird. So I'll just get you guys to search yourselves. But it's tragic airplane accident. Biplane loses power on takeoff. Have you guys seen that one? It's not a nice video. But it gets the point across. This I wrote nothing.
Oh, yeah, he's pretty brutal.
Biplane loses power on takeoff as well. That's what
Oh, I think I have seen that one. Yes, it is this video. I remember this one.
Did you guys get shot at in your? Yeah.
I think that or I've just seen it
Yeah.
in my own time. Actually.
So you can see why it's a good video for this mess brief. So it's exactly what's happened, right?
How's that on the news?
Yeah, it's crazy, yeah. News doesn't put that stuff on TV anymore because they're competing with the internet anyway. Anyway. Has everyone watched it?
I'm getting traumatized. Thanks.
Sorry,
Go cry list.
I traumatise some students now. Cool, so that just really emphasises the point that this slide is trying to make. Why we don't turn back, because you won't be able to aviate correctly, you will lose too much height too fast, you just don't have the time. Yeah, everyone happy with how they can make that point to the students now? Make them sad. I guess another thing to note is we didn't even discuss Palmerston North's elevation on top of all that. Because were we talking about 600 feet indicated or AGL? Exactly, dears. Who knows? Because we usually turn at 650, right? So if it's after takeoff, then it's. I mean, it could happen at 200 feet as well. You just don't know. Is the point there? So don't forget about elevation as well, and how much height that actually gives you above ground. Something to think about if you are taking off at a place like Topol. Right, carrying on from writing your, can I run this up?
Yeah.
So hopefully you wrote up on the board your initial actions, and now you can start writing up the checks as well. So aviate, navigate, do some checks. This is you telling the students homework, right? Memorize these. We need to have them memorized because they need to happen automatically. They need to be an automatic response as we brushed on at the start with our objectives. what does touch check mean? This is the time to discuss with the students. So in an actual engine failure, you will go through and you will change the tanks. You will make sure it's full rich. You will turn the fuel on. You will open the alternate air and you will make sure your pressure's on both. If we are practicing, you will say simulating before everyone, which it should. I might say it might recap this a bit later, but it's a good time to talk about it now. Anyway. So what does simulating mean? If I do not say simulating, you treat it like it's real. Yeah, if I'm happy with that, lay that out for the students really clearly. If I say simulating, you're going to do touch checks for those two things. So you're not actually going to change the fuel tank selector, you're going to touch it. So physically, I want to see you touch the thing. Same with alternate air, touch it. What I don't want to see is waving over it like that did anything. I have heard stories of people getting so used to touch checks that when an actual failure happened, they touched the thing and expect that to fix it. You guys have heard that story?
Russell took me for a flight and in the twin.
Yeah.
And he'd sneakily put the flap back down and not arrange it and stuff like that. So then when I do my touch checks, I just actually touch from not check it and I'll flap it down or something.
Okay, yeah. So you would just.
Yeah, I would flick a switch on, make sure I actually turn it on.
Yeah, I was. Richie told me that story from. This was back in the day when they were pretty loose. He actually just turned the fuel tank selector off on the student download. Yeah. And so they did that, and so he didn't say simulating, they had an engine failure and the student just panicked and touched everything. And he went, just turn that on, like, you know. Like I said, it's back in the day, you wouldn't get away with it now. But it was a very good lesson for that person to learn, right? Of actually, oh look, if I just do the checks, I would have saved my engine. Yeah, so point out what these checks are actually going to do. Remember we talked about those reasons we can have an engine failure. These things all kind of relate to those one of those 4 items, right? And we're checking if there's something we can do simply as the pilot in the seat to actually remedy the problem. When PK was telling me about his engine failure for takeoff, he said he ran through those checks like 8 or 10 times. That's how much time he actually had to go through it. And he just kept doing it. He kept going over and over, just hoping that it would fix it. But of course it didn't.
Sorry, was it a full engine failure or just a partial engine failure?
Full engine failure, and they turned back and landed on the field. Because they must have had quite a bit of height. It must have been like decent wind, and like he said, he went through those checks so many times that they must have plenty of time. They could have probably only turned onto like a base or something. Sorry, crosswind. Shutdown checks, what's the purpose of these?
Fire.
Reduce risk of fire? Yeah. So still important for the student to learn, but it's just if there's time, right? So turning the fuel off was stopping the fuel from moving around the aircraft. Hopefully that will reduce the risk of fire. Turning the ignition off, we're getting rid of that spark. Turning the masters off, we're reducing the risk of electrical fire. Cool. Mayday call, once again they should have done Efato by now, so it should just be a reminder. Get them to do the example for you. What does squawk 77 on the transponder mean? Going to heaven.
Hopefully you're not going to heaven and you survive, but
it should come up later, but you could point out here that communicate if there's time once again. And yeah, we'll recap it soon. Effective flat, so this should be a recap again. If we lower flat, what happens to our angle of descent, what happens to our rate of descent, what happens to our range, what's going to happen to our forward visibility, what's going to happen to our stall speed, what's going to happen to our landing time. All just questions, and note it comes up with the thing and then the arrow, so you can actually just take your time. Bring it up, ask them what happens to landing line, bring it up. Note the colours of the arrows, so the first 3 are kind of considered bad, but it's going to depend, right? In my mind, it's not really bad. You might need to reduce the range to get into your field. So there's good and bad things to all. Just doing an aborted takeoff. Really important that we're going through our aviate, navigate and communicate here. This is where we really might not have time, so don't stress too much about the communicate, just make sure you're aviating, navigating. And you can go through the same stuff. Why might we do an aborted takeoff? And remember, bring it back to the takeoff brief. Any abnormalities, I will abort. So this is, bring it back to that and then ask them, what would count as an abnormality? And you can go through any caution or alert coming up. I've had someone abort a takeoff because the fuel selector warning or fuel tank change warning came up, and they aborted. And it was like, cool, like that's something abnormal happened that you weren't expecting, and you aborted. Like, fantastic. And you know what? We just taxied back and took off again. Wasn't a big deal. So it's make sure they stick to that. Any abnormality. And the amount of times I do one of those emergency sims where I just put some sort of abnormality up right as they go full power, and they look at it and go, oh, okay, and then they carry on and take off. And so they're like, you said it, any abnormality. If an overrun appears likely, then you can go through that FIM again. For some reason it's, oh no, it's because it's something different. I always still use FIM though, because I'm still going fuels, ignitions and masters, so I don't know why they changed it around here. Personally, that's what I do, and I don't see an issue with it. Keep it simple in my mind. I'm doing the same checks essentially. So anyway, let's breeze over that, and I'll let you guys decide how you want to tackle that. Personally, just stick to your phone. Navigate-wise, keep the cabin intact, as we've discussed. Steer between obstacles. Think about crash position, seatbelts. All that good stuff. So situational awareness, always important, but really significant here because we're doing a takeoff brief to improve our situational awareness at the start, right? We need to make sure we've considered all the things worth considering. Where the good options are if we have an engine failure, what the wind's doing, how that's going to affect. What kind of takeoff we're doing. Information processing, the point of that brief is to help us in regards to our information processing. So when we have an engine failure after takeoff, we're not sitting there going, oh wait, where were the good fuels? What was the wind doing again? All that stuff is accounted for. So there shouldn't be much brain work required. So you've got plenty of time for brain panic. And you can just do what you said you were going to do. Of course, it's going to be stressful. It's going to be one of probably the most stressful things you'd ever encounter flying. So, overlearning our checks on the ground. We will practice this plenty, and we are looking to develop that automatic response as mentioned. Hopefully, your guys' instructors have thrown these at you, not just after takeoff. Hopefully, you've been low flying or something, and your instructor's giving you an engine failure. Has anyone experienced that? Yeah, tears. No? So I find it's quite good to just. Usually it's like I'm just low flying with a student, hopefully a little bit above 500 feet. And I tend to do it after a precautionary. So they're just on a precautionary, they're climbing away and they're all happy with themselves and they're simulating. And it's just to really make you click on, that's still the same procedure, eh? You're still just going straight ahead. It's nice for after a precautionary because ideally they would have lined themselves up with the wind anyway. So it works quite nicely, don't want to be too mean to them. But I mean, that's what I had for when I was a student for my P3 FE, was after the PFL, I went around and then I got an engine failure straight after it, which was nasty, but also not too bad at the same time, because I was like, well, I'm only going here, I only had one option. But that can be quite good just to help really test that automatic response for your students. But the big part with all that briefing is hopefully that we're really pushing that command decision making, right? They've gone through everything they're going to do. They've told you in their brief, this is what I'm going to do. So make sure they're doing it. it's always good to test any kind of briefing that they do, that they will follow it. Or else if they're not following it, what the hell are they talking about then? What's the point? Right, now let's talk a little bit about the partial engine failure. Now this slide is just a lot of questions because that's all it is considerations in regards to what do we do. So you may be able to adapt the procedure, however you've got all these things to consider. And at the end of the day, before you read through this big list, the option is always, there's always the option to just close the throttle and treat it like it's been a full engine failure. Because that's what we're going to practice. We don't really practice partial engine failures. So as we can see with these questions anyway, how much power is available? Are we able to maintain height or even climb, or are we descending? As it says, or will the partial power only be able to extend your glide range? So that might be, you know, just what we need. We've had an engine failure quite low to the ground, we don't have any options, but we've got just enough power to just drift us over to an actual option. Think about like those options we saw at Wellington or Wanganui and how they're not great, so maybe we've got a little bit of power that can just get us to a nicer part of the beach or just get us around the corner where it's a bit calmer from Wellington, you know? If you can maintain level at what speed, can you turn, or is the aircraft likely to stall? So what is the performance? Can we actually change direction, or is that not an option? How high is it happening to us at? And this is where you can brush on forced landings, where we look at landings, or sorry, forced landings where we're at about 3,000 feet. Pretty much anything above 1,000. But engine failure to takeoff. Are we at 700? Are we at 200? It's going to be a big difference on how much you're able to get through, right? You guys all practice in the twin engine failures that happened just after you rotate. Yeah, so lots of different things we can talk about there, but let's keep it simple, yes. What caused the engine failure? Is a total engine failure imminent? So yes, we've had a partial engine failure, but are we expecting it to stop any second now? You know, are we actually getting a bunch of rough running and the engine can stop any minute? Which is pretty much what happened to Ross, right, in this last one. Are there large vibrations when power is used? Should you even consider adapting the procedure? So that last question is what we kind of started with, right? Should we consider adapting, or should we just close the throttle, turn the fuel off, and glide somewhere? Lots of questions. We can't give an answer to until we know all the context of the situation. So that's where you have to really adapt the procedure and decide what's best at the time. Remember, any landing we can walk away from is a successful one. That's the thing to point out there. Right, because we already brushed on these, we can dive through this slide pretty fast. So we talked about the reasons we could have an engine failure. What can we do to avoid an engine failure then? Thorough pre-flight, thorough run-ups, make sure it's maintained. Think about looking after your engine, T's and P's, doing engine warms, all that good stuff. Have we all done a PFL and forgot to do engine warms when you go full power and you get a bit of rough running? And you go, oh, shouldn't have done that. So look after your engine. That can be something right now to the students. This is what will happen. Shock cooling, your engine will explode. That's it, I'm struggling with that. Previous. Yeah, maintenance is somewhat out of our hands, but we can aid in spotting any abnormalities on the aircraft and getting them sorted out before flying. Just like we always talk about how controllers are people and they will make mistakes. Engineers have many safeguards to stop them from making mistakes, but we are also one of those safeguards in regards to the aircraft, right? Preventative actions, so just recapping avoidance. SOPs, hand on throttle at all times below 1,000 feet. We do not do any solo practice for Efatos. They are only to be done with instructors, and that includes your guys' solo flights and FIC, correct? So you don't have your pilot monitoring, simulating on or anything like that. So commences when the instructor closes the throttle and says simulating. Touch checks only, concludes with go around. I did a flight with a student not that long ago. We were just doing circuits. I wasn't the primary instructor, I was just helping out. And I told them to go around on an Efato, and they didn't. So I said it again, and then I took control and went around. And when I asked them like what the hell was going on, why didn't they go around, they said, oh, I thought you were supposed to say simulation complete. So just make sure it's clear about which I don't know where they got that from, because talking to their primary instructor, they didn't know where the hell that had come from. But just look out for things like that, you know, make it really clear. I will just tell you to go around when I'm happy that we're done. And you do have to speak loud and clearly at that point too, because usually you're very, very focused. Do not go below, this is for you guys, as future instructors, do not go below 200 feet AGL. Don't take these too far, they don't need to go that far. All you really need to see is that they get their best glide speed and they go for a clear area. I like to see people using flat if they need it. Some people kind of just assume they don't even bother because they know that they're going to get told to go around pretty soon after. But, you know, it's usually a debrief point of mine is you need a flat to get in there, you should use flat. But yeah, do not go too low. Even though, as you guys know, the law lets you go below 500 for the point of instruction, doesn't mean to push that limit in. Hopefully we've answered that question a few times and asked it a few times. This is quite a good way of actually really emphasising that point of just, it's all about surviving here. So what this is showing us is at 75 knots, in order to stop within 8.2 meters, you can achieve a 9G deceleration, which is a survivable amount of Gs. That's what it's trying to say there. So what we're saying is even if you hit some obstacles and you have a really crappy field that you've hit, or the clearest area is not a good clear area, you still have a really good chance of surviving if you keep the aircraft under control. So a controlled crash, which is kind of what every landing is anyway. Cool, everyone happy with what that table means? Now that doesn't mean if you go 45 knots you only need 3 meters, point it out. We still want to achieve our best glide speed. Yeah, but that's all that on tables trying to say. And then that's the last slide, so you're finishing off with just saying homework is learn those checks. Learn those drills and hopefully you've written up, you know, your initial actions, 75 knots, best glide. Then you've got your checks underneath, you've got your aviate, navigate, communicate if there's time. You've recapped all of that and you've told them what you need them to know before they do this flight. Cool. Any questions about that one? How long did that take us? About 30 minutes, isn't it?